Okay, last example for this section on 7.7. Let's solve this equation. And this time we have a secant, yuck, and a 3 theta over 2 inside, and we have a minus 2 on the outside. Okay, now let's think back. What does a secant, since I don't like working with secants, let's convert it to cosine or sine, whichever one that is. Remember that the secant is the reciprocal. Okay, secant of some x is the same as 1 over the cosine of x, right? So the cosine of x must be equal to 1 over the secant of x. And these are reciprocal relationships, right? So when I do, what I'm going to do here is I'm going to try and rewrite this as a cosine. Okay, so I'm going to say cosine of my angle. My angle stays the same, right? The secant of x and the cosine of x here are the same, or sorry, the x stays the same. So now if I flip this, if I rewrite this in terms of this is going to be, well, this is going to be cosine of 3 theta over 2, and that's equal to what? Well, that's still negative 2, right? Let's rewrite this again. I'm going to say if I flip this side, I can flip this side, right? 1 over 3 is the same as 2 over 6. If I were to flip this side and say 3 on this side, I would have to flip this side and get 6 over 2. Okay, this is still the same statement. So what I'm going to do is I'm going to flip this side and flip this side, and I get cosine of 3 theta over 2 equal to, and I flip this, since this is minus 2 over 1, then I'm going to get minus 1 over 2. And now we're back to the same problem that we had before. In the previous examples. Okay, so let's find out where the cosine is equal to negative 1/2. Well, where's the cosine negative? It's definitely not negative here, and it's definitely not negative here because ASTC, right? So it's got to be over here. And negative 1/2 belongs right there. Okay, so we have these 2 points on my unit circle. And let's think about what those angles are. 3 theta over 2 is equal to what's my angle from right there? Well, that would be cosine of 60, right? That would be cosine of 60 is negative 1/2, so that would be pi over 3. And so this angle would have to be 2 pi over 3. Okay, so that would be 2 pi over 3. That angle would then be 2 pi over 3 plus pi over 3 plus pi over 3, so that would be 4 pi over 3. Right, so I have two situations here. But am I done? Well, I still need to check how many times I need to turn by changing my domain. Okay, so this is true only if theta, I need to make the inside be this. Okay, so how do I do that? I need to multiply this side by 3 over 2 and multiply this side by 3 over 2. If I multiply this side by 3 over 2, I still get 0. If I multiply this by 2 pi times 3 over 2 is going to be 3 pi. So I need to go from 0 to pi to 2 pi to 3 pi. So I actually have one more half revolution to make, right? Because that's 3 pi. So my third one would be this plus 2 pi, because that'd be one revolution. That'd be 2 pi plus 2 pi over 3. So I'd have 2 pi over 3 plus 2 pi there. Okay, so let's see what this turns out to be. Well, I'd have 3 pi over 2, or sorry, 3 theta over 2 is equal to 2 pi thirds, 4 pi thirds, and this would be 3 over 3. That would be 6 plus 2. That would be 8 pi over 3. All right. Now I need to convert this into I need to convert these back into my original theta. So I have 3 solutions for this range. Now let's get this back into just theta. So I need to multiply everything by 2/3, right? Multiply all of these values by 2/3. Okay. and these will cancel, so I'd be left with theta over here. 2/3 times 2/3 would be 4 over 9, 4 pi over 9. That would be 8 pi over 9, and that would be 16 pi over 9, and those would be my three answers. Okay, these three answers will make this statement, this side, equal to -2. Alright, this is also called the solution set, and you can, that's the set of, technically I'd have to put these curly brackets, okay? This would be the set of numbers that would make this statement true. Alright, well that's it. Thank you for listening.